A lot of the ancient gods and goddesses, always depicted in things like this. Isis, the queen of heaven, unveiling the mysteries. Now, why is she standing in a lunar crescent? Well, there is the scientific tradition of the moon, and there's the ancient, the traditional. I happen to think that the two actually complement each other. And what we can't learn from looking strictly at the science, we might be able to fill in some of those gaps by looking at some of the traditional accounts, and vice versa. Some of these quotes are quite interesting. Let's see here. It is far easier to explain why the moon shouldn't be there than to explain its existence, said MIT geophysicist Nafi Tiksaz in 1981. Nobel physicist Harold Sayuri said all explanations for the origin of the moon are improbable. None of them make sense. Eric Chason in Cosmic Dawn, 1981, said perhaps the formation of our moon was the product of circumstances so rare that we will never be able to unravel the details of its birth. Indeed, the origin of Earth's moon is a frustrating subject, so perplexing that some researchers have been forced in desperation to suggest that the moon does not exist.
We've long considered the moon to be just a gray, dusty companion of Earth, a byproduct of a cosmic collision or leftover debris from Earth's formation. However, upon closer examination, this narrative seems increasingly inadequate. The moon presents numerous anomalies, from its behavior to its composition, that challenge our understanding and suggest a more complex history.
The moon is definitely anomalous. It's very difficult to explain. The first clue is the obvious one when anybody is paying attention to the moon. Observe that no matter what time of day or month or year you look at the moon, the same face of the moon is always facing the Earth. Why is that? If you start getting enough mass together, it's eventually going to consolidate and assume the geometric form that requires the least amount of energy to maintain, which is a sphere. Now, if you have a very small, like an asteroid, it doesn't have to be spherical. I mean, it can be long, it can be misshapen. The moon, though, has enough mass that it should have settled out to a homogeneous sphere. But it hasn't. That's the testimony of the moon with its face turned towards us at all times. If you had a homogeneous sphere, then Earth's gravity field would act upon that homogeneous sphere as if it was a singular point. And it would be free to rotate on any axis independent of Earth's gravity field. But it's not doing that. It means that for somehow, it's almost as if the mass of the moon is towards the outside of the moon rather than the moon's center of mass.
Let's start with something measurable. The moon's density. It's only 3.34 grams per cubic centimeter, just over half of Earth's. For something that size, it should be denser. That discrepancy alone raises eyebrows. But it gets stranger. During the Apollo missions, NASA deployed seismometers on the lunar surface. When they intentionally crashed lunar modules or triggered artificial quakes, the moon didn't shudder like Earth. It rang. Vibrations continued for up to 3 hours. Scientists described it as a bell-like resonance. And they weren't using metaphor lightly. That kind of sustained ringing doesn't happen on a solid planet. It implies a highly rigid, perhaps partially hollow structure, something that reflects seismic waves rather than absorbs them. In 1970, Soviet scientists Mikhail Vasin and Alexander Shcherbakov proposed something radical, that the moon might not be natural at all. Based on its low density, seismic behavior, and orbital perfection, they theorized it could be a planetoid engineered by intelligence, a kind of shell, perhaps even a repurposed body. Even if you don't buy the artificial hypothesis, consider this. NASA itself acknowledges that the moon's center of mass is nearly 2 kilometers closer to Earth than its geometric center. That's a big deal. It means the mass isn't evenly distributed, which could account for some of its odd behaviors, like its perfect rotation lock. But it also defies expectations for a naturally formed object. Earth's moon is unique in both size and position compared to the host planet. No other planet-moon relationship in the solar system comes close to matching it. And here's what that all adds up to. The moon doesn't act like it should. Is it a relic of some ancient mechanism? A protective construct? A cosmic anomaly we barely understand? Whatever it is, and the mystery isn't just up there in the sky. It's written into seismic graphs, gravitational equations, and ancient lore. So here's the next puzzle piece. Why does the moon always face us with the exact same side? Seriously, every time you look up, it's the same face, same craters, same features. No rotation from our point of view. This isn't a visual illusion. It's real physics. The moon is what scientists call tidally locked to Earth. And while tidal locking isn't unheard of in the universe, what makes Earth's moon so bizarre is just how perfect and stable this lock is, especially given all its structural imbalances. To understand how odd this is, let's zoom out. Most moons in the solar system wobble slightly, tumble over millennia, or experience tidal drift. Not ours. Earth's moon is in a finely balanced orbital state where its orbital period exactly matches its rotational period, down to the decimal. That means as it orbits us once every 27.3 days, it rotates exactly once in the same amount of time, keeping one hemisphere perpetually facing Earth. This wouldn't be quite as jaw-dropping if the moon were a uniform sphere. But it's not. NASA data confirms that the moon's center of mass is offset by about 1.8 to 2 kilometers toward Earth. That's a huge deviation, and it makes the lock even more uncanny. It's like trying to spin a lopsided coin that always lands on the same side. And then there are the mascons, short for mass concentrations. These are incredibly dense pockets of material buried beneath the lunar surface, mostly beneath the moon's dark basins, the Maria. These mascons distort the moon's gravitational field. When NASA first launched unmanned lunar orbiters, engineers were shocked to find their trajectories subtly altered as they passed over these areas. It was as if something beneath the surface was tugging at them. Now imagine what mascons would do to a spinning, orbiting body over millions of years. They should create instability, a gravitational wobble, or even orbital decay. Instead, the moon stays locked in perfect synchrony, like a massive clockwork mechanism with counterweights precisely in place. So how is this precise equilibrium maintained? That's still debated, and when you consider that this alignment allows for another phenomenon, perfect solar eclipses, where the moon precisely covers the sun, it adds another layer of strangeness. Let's put this in perspective. The moon is 400 times smaller than the sun, but it's also 400 times closer to Earth than the sun, resulting in a perfect match in angular size when viewed from our surface. That's like parking a dime 10 feet away from your eye and having it exactly cover a street lamp 4,000 feet away. Cosmic coincidence? Sure, maybe. But it's just one more in a long string of numerical and mechanical oddities that seem less like random chance and more like intelligent calibration. And here's the kicker. Without this synchronization, life on Earth as we know it might not exist. The moon's gravitational pull stabilizes Earth's axial tilt, which controls our seasons. Without it, the planet could lurch from one tilt extreme to another over millennia, bringing about radical climate shifts that would make long-term life incredibly difficult. So the question is no longer just, why does the moon always face us? It's, why is it doing so with such precision and to our benefit?
We couldn't exist without the moon. First of all, like if let's say you're a planetary engineer, you're designing a planet, and you're going to seed that planet with life. But in order to do that, you have to have a watery matrix first. You introduce the precursors of life into water. But in order for that life to evolve to higher levels and eventually to have the ability to think and reason and all of this, you have to go through a long sequence of stages, right? Just taking the example of the Earth, how do you get life from the oceans onto land? You have to have that transitionary zone so that there can be creatures that can actually exist in both realms. And that's your intertidal zone between low tide and high tide. So it's been pretty much surmised that without the moon, there wouldn't be an intertidal zone, and without an intertidal zone, it would be very difficult to get life from the oceans onto the land.
Okay, let's get bold, because this is where things get truly bizarre. During the Apollo missions, astronauts placed seismometers on the lunar surface. The expectation was simple: record a few tremors, chart some moonquakes, learn about the interior. What they got instead was something nobody expected: When Apollo 12's lunar module was deliberately crashed into the surface, it set off a moonquake. But instead of tapering off quickly like an earthquake, the seismic waves rippled for nearly an hour. The moon didn't just vibrate, it rang like a bell. The reverberations were so strange that NASA's lead scientists were left stunned. One report described the vibrations as being akin to a gong being struck. Why is that weird? Because on Earth, seismic waves travel through solid rock, spreading out and weakening as they go. That's why earthquakes don't ring our planet like a bell. But the moon? It bounced those waves around like a hollow or rigid object, as if something inside was reflecting the energy rather than absorbing it. And this wasn't a one-off. Apollo 13's SIVB stage, a 15-ton rocket booster, impacted the moon, and the resulting tremor lasted more than 3 hours. The signal was uniform, controlled, and eerily sustained. So what could explain this? Some researchers, including Soviet scientists Vasin and Shcherbakov, proposed a radical idea in the 1970s. Maybe the moon isn't solid at all? They introduced the hollow moon hypothesis, suggesting the moon's interior may contain massive voids, caverns, or even an engineered honeycomb-like structure.
The density of the moon is only slightly more than half the density of the Earth. Okay, so if you had a big giant ice cream scoop and you scooped out a spherical volume of the Earth, it would be almost twice as dense as the moon. Yet, because of the fact that the moon has one-to-one spin-orbit coupling, the fact that it doesn't matter how wide the craters get, they typically don't get more than 3 miles in depth, and the fact that you've got these gravity anomalies that seem to sit at the center of each Maria, all of that seems to suggest that the moon is an extremely rigid body and that its mass, a lot of the mass, is towards the outside rather than the inside. Now, if you want to create the maximum area of surface area to volume, the bees show us how to do it with their honeycomb, right? And also, a honeycomb, given its weight, it's a pretty strong structure. It's very, very low density, but it's a relatively strong structure. If the moon was honeycombed, and there is some theoretical evidence to suggest that the mass could be honeycombed, in other words, really big caves throughout the mass of the moon, although there seems to be evidence that there is a solid core, a dense solid core. What I'm thinking now, if you cut the moon through the middle, you've got a rigid shell, you've got a dense solid core, and in between you've got almost like a honeycomb structure. And I think that seems to be, at least the papers I've read and so forth, seems to be a model that could be most effectively representing the structure of the moon.
Sound far-fetched? Let's walk through the science. The moon's moment of inertia factor, 0.393, is much lower than Earth's, 0.33. This indicates mass is concentrated closer to the surface, not toward the core. Lunar impact craters, even from massive meteoroids, are surprisingly shallow. You'd expect deep bowls from collisions at cosmic speeds. Instead, you get wide, flat depressions, almost as if something is stopping the impacts from going too deep. Density gradients show sharp variations, not the slow transitions you'd expect in a planet that formed naturally through accretion. These findings support the idea of a rigid outer shell with internal voids, possibly even gas pockets or large caverns. Some models propose a crust that's 30 to 40 kilometers thick, sitting over a less dense, more echo-prone interior. That might also explain why some parts of the moon are almost impervious to impacts. If there's a reinforced shell beneath the surface, something akin to a load-bearing structure, then it would redistribute shock waves, dampening the effect of collisions. Think of it like a cosmic crash helmet. Now, to be clear, hollow doesn't necessarily mean completely empty, and certainly not that it's a spaceship. But what it does mean is that the moon's interior may be more complex, layered, and engineered than any naturally formed satellite should be. Even NASA scientists have referred to the moon's seismic anomalies as unearthly, which is a fascinating choice of words. So here's the big question. If the moon were formed naturally, why would it ring like an artificial structure? Either the moon is playing by rules we don't yet understand, or someone or something built it to behave this way. If the moon's interior is strange, its surface is even stranger. You've probably seen images of the moon's craters, millions of them, etched into its face like scars. But there's something most people don't realize. Many of those craters are shockingly shallow, even the largest ones. For example, some lunar craters span hundreds of kilometers in diameter, yet none go deeper than about 3 miles. That's not how impacts are supposed to work. When massive meteors hit Earth, they dig deep bowls. On the moon, that energy seems to flatten out, spreading laterally rather than vertically. So why don't impacts burrow deeper? One theory is that the moon's crust is behaving like a reinforced outer shell. The idea is simple. If the surface is structurally rigid, not just solid, but engineered to distribute force, then shockwaves would bounce sideways instead of punching through. Imagine trying to dent a steel helmet versus a piece of clay. You'll get a mark, but not much depth. And now the chemistry comes in. Because what we find in moon rocks adds another layer of mystery. Apollo missions brought back samples from various regions, and many of them are packed with high-performance metals. Titanium, zirconium, yttrium, niobium. These are refractory metals, meaning they have incredibly high melting points, and are known for their use in aerospace and military applications. Some lunar soils contain up to 10% titanium compared to Earth's richest ores, which hover around 1 to 2%. That's not just unusual, it's suspicious, because it's not just the presence of these metals, but where they are found. These high-density, heat-resistant elements are often clustered near the moon's gravitational anomalies, the mascons. So we've got craters that don't go deep, armor-like materials near areas of gravitational disruption, and structural resilience where you'd expect fragility. It begins to look less like the battered surface of a dead rock, and more like a skin designed to take punishment. And what's below that armor? Well, we don't know for sure. But if there's a reinforced crust with pockets of helium-3, it could mean the moon isn't just tough, it's storing something. Also worth noting, the far side of the moon, the one we never see, has far fewer maria, the dark flat basins, and a crust that's roughly 15 kilometers thicker than the near side. That's a huge asymmetry. If the moon were just a naturally formed satellite, its crust should be more uniform. Instead, it's as if one side was deliberately constructed to face Earth, protected, dense, and rich in strategic materials. So let's take stock. The moon's surface absorbs and spreads impact energy like engineered shielding. Its rocks contain anomalous concentrations of space-grade metals. Its structure seems optimized not for geological randomness, but for resistance. What kind of object behaves this way? Not a dead satellite, not a coincidence, but maybe a vault, a machine, or a deliberately armored outpost. Thousands of years before the Apollo missions, someone was already paying very, very close attention to the moon. From the British Isles to Mesoamerica, across deserts and jungles and mountains, ancient civilizations erected megalithic observatories that align not just with the sun, but with the moon's complex 18.6-year cycle. These weren't random rocks, they were calibrated instruments.
This is a very interesting study by Alexander Thom. He was a Scottish engineer who spent many years surveying megalithic sites around the British Isles and Europe. And he wrote a whole book showing that they were constantly, repeatedly being used as lunar observatories, which raised the question, why were so many ancient people building these monuments to the moon? And observe, you'll notice here, look at this. Here's Stonehenge, the larger one. Over here you've got the most southerly moonrise, most northerly moonrise. So within this structure, they've got not only the limits of the moon's motion, the sun's motion as well. So here you got this huge structure, would have taken enormous amount of labor to construct. And it's, in a sense, an astronomical observatory where you can make very, very precise observations of the motions of the sun and the moon throughout the year, which again is not consistent with what you would expect hunter-gatherers needing to do, right, or even subsistence farmers. It said, well, this is how they could, tell the seasons when it was time to plant and so on. And, well, yes, that's true, but you can also do that with just a stick in the ground. So why are you going to be moving 20-ton stones all over the place and this? It just doesn't add up.
Let's start with Stonehenge. It doesn't just frame solstices. It also tracks the moon's northernmost and southernmost rises and sets, movements that shift subtly over nearly 2 decades. To build something that follows this cycle, you'd need not just observation, but patience, record-keeping, and an understanding of celestial mechanics that seems impossibly advanced for a society without telescopes. Then there's Newgrange in Ireland, Chaco Canyon in the American Southwest, and Mayan temples in Guatemala and Mexico, all constructed to mark lunar standstills, eclipses, or precise moon phases. These weren't agricultural tools. These were calendars of the cosmos, and they weren't isolated. Across the ancient world, cultures seemed to encode lunar awareness into stone, often combining it with stories, myths, and sacred numbers. Some, like the Dogon tribe in Mali, claimed to know about invisible stars and planetary orbits long before science could confirm it. Others, like the Zulu, told oral histories of a time before the moon existed, when the skies were different, and something massive arrived and changed the world. Now sure, myths aren't peer-reviewed science, but they're cultural memory, passed down through generations, and they often preserve patterns of observation we've only just begun to appreciate. And here's where things get numerically weird. The moon is approximately 2,160 miles in diameter. Its average distance from Earth is about 216,000 miles. The number 216 shows up again and again in ancient texts, temples, and rituals, particularly in Hinduism and Buddhism, where prayer malas have 108 beads, half of 216. Sacred geometry? Possibly. The Earth's precession, the slow wobble of our axis, takes 25,920 years. That's 216 times 120. It's like the cosmos left breadcrumbs, and the ancients followed them. And what about eclipses? The moon and the sun appear exactly the same size in the sky, even though the sun is 400 times wider, because it's also 400 times farther away. That's an absurd coincidence. Or is it? Perfect solar eclipses, where the moon completely blots out the sun, only happen because of this precise ratio. No other known planet-moon pairing produces this effect. And guess what the ancients did? They aligned calendars to track these events, even timing ceremonies to them. To them, this wasn't random. It was sacred, designed, a cosmic message written in the sky. So we're left with a profound question. How did cultures with no satellites, no telescopes, and no global communication know so much about the moon? Were they just gifted observers? Were they inheritors of lost knowledge? Or were they trying to tell us something we've forgotten? Because if ancient builders across the planet all agreed on one thing, it's that the moon matters more than we realize. It's even been proposed by researchers like Randall Carlson that the moon acts as a kind of cosmic memory bank, a lunar ark, built to preserve knowledge or anchor stability through global cataclysms. Maybe that sounds wild, but then again, so does the moon. Every anomaly, every number, every alignment, it all seems to whisper that the moon isn't just there. It's doing something, watching, influencing, holding the balance, and maybe, just maybe, waiting.